Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, Professor of Mathematics at Cosumnes River College in Sacramento, California. This video is dedicated to converting equations from rectangular to polar form. It's a continuation of a bunch of videos on the polar coordinate system. You should have already watched all the videos up to this point in this topic, so you should know what the polar coordinate system is. You should know how to convert between polar and rectangular coordinates, and the video prior to this was how to convert from polar equations to rectangular equations. Now we're going from rectangular form into polar form. So basically our standard equations that we're so used to, and then we're going to convert those into polar equations. We want to see what their equivalent is. And so here I'm just going to paste in my conversion formulas there. One thing I want to note is it's very easy for us to graph these by hand because we're so used to them. So x equals 3 is a vertical line, right? X equals 3. And so we would love to know, how do you create that same vertical line in polar coordinates? The way you would go about doing this is really just look at your conversions. X is the same thing as r cosine of theta. So this equation is r cosine of theta is equal to 3. Now, it is up for argument as to whether or not you have to solve for r. I would say just be careful, just in case, go ahead and solve this for r. R is equal to 3 over the cosine of theta, or in other words, 3 secant of theta. I think it's probably a good idea to always solve your polar equations for r if you can do it. Sometimes you just can't, and we might run into examples like that. But turns out the equation of that vertical line is just r equals 3 secant of theta. Nothing too terrible. Likewise, in a problem like this, it really is, again, not too terrible to rewrite this equation in terms of polar coordinates, or in polar form is what we call it. We know that x is the same thing as r times the cosine of theta. We know that y is r times the sine of theta. And you can actually solve this for r by factoring an r off of both of those terms, and then dividing both sides of this equation by cosine of theta minus sine of theta, and arriving at r is equal to 5 over cosine of theta minus sine of theta. We saw in the previous video a problem very similar to this. I think it was a 1 over 4 cosine of theta minus 3 sine of theta, and we got that to be a line in the Cartesian coordinate system. And now we start with a line from the Cartesian coordinate system and end with a polar form that is very similar to what we saw in the last video. You will not often work with lines in the polar coordinate system, so don't freak out and think that you need to memorize this form. You're just getting used to converting, that's all. In this next example, we're going to go ahead and take a look at a more complex looking rectangular form equation. Still, we're kind of lucky here. X squared plus y squared we know is going to be r squared. So let's go ahead and plug that in. So we get r squared. And then 4 times x. Well, x is r cosine of theta. So this is r cosine of theta. Now, be honest with you, I often had issues with what would happen next. If you're working in an online homework system, or if your instructor requires it, they want you to answer r of theta is equal to something, right? So they want you to solve this equation for r. However, as written, you can't technically solve for r if r is 0. So assuming that r is non-zero, you could divide both sides by r to get the following. If you divide both sides by r, you get r is equal to 4 cosine of theta. That is likely what your instructor would expect you to respond with. However, there is a slight issue here. The slight issue occurs with the fact that r could technically be 0. However, this condition only will occur if theta is pi over 2 or 3 pi over 2 or an odd multiple of pi over 2, which forces r squared to actually become 0, or in other words, forces r to become 0. And that condition still holds here. I know that may not make sense to you, but for right now, just know that you can technically, well, you can divide both sides by r as long as both terms have an r in them. If there is an extra term out here, let's say it says +1, then dividing everything by r is sort of a no-no, because you don't know if r is going to be 0, and that's an issue. But when you don't have an extra term there and all your terms involve r, you could technically factor out that r and get rid of it because it still is there. You didn't really kill anything off. So anyhow, it's an awkward situation to talk about, but the reality is for most of the vast majority of problems you're going to be doing, you can just divide both sides by r there and you get r is equal to 4 cosine of theta. As a final example in this section, let's take a look at converting this equation to polar form. And this is a fun equation. If you take a look at x there, you could say, okay, well, actually, let me paste in our formula set. So now we have that. And I'll go ahead and just say x is equal to r cosine of theta minus 4 being squared plus y is r sine of theta, so that's r squared sine squared of theta, and this side is 16. Now, as I was mentioning in the last example, if this was, let's say, r there, you could not divide everything by r because this does not have an r in it, and you'd possibly be dividing by 0. So that's just my heads up from the last example. Now, you would be incorrect if you were to just say this is done. You want to solve for r. You want to get r is equal to, if you can. And you actually can here. If you do the binomial distribution here, you'll get r squared cosine squared of theta minus 8r cosine of theta plus 16 plus r squared sine squared of theta is equal to 16. You can see that subtracting 16 from both sides gets rid of those constants. And then r squared, these two terms, let me highlight them. This term here and this term here with r squareds, I'm going to gather those up and factor an r squared out. If you do that, you get r squared times the quantity cosine squared of theta plus a sine squared of theta, which is the Pythagorean identity, minus 8r cosine of theta is equal to 0 because we subtracted 16 from both sides. So remember, cosine squared plus sine squared of the same angle is just 1. So that's r squared is equal to 8r cosine of theta. And you can now divide both sides by r. In reality, actually what you're doing, maybe this would have been a better discussion on the previous page, is you're saying I'm going to factor r out of both sides to solve this, and you would have had r times r minus 8 cosine of theta equals 0. There's only two solutions to this. Either r is equal to 0, identically and always, or r is equal to 8 cosine of theta. And that is our equation. R is equal to 8 cosine of theta. Or you could have just solved this for r by adding 8r cosine of theta to both sides and dividing both sides by r. You would have arrived at the same formula. A little bit of an awkwardness on that, but still very neat. And we are done with this video series.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You inside that doesn't justify you to speak too loud and cry.